Think about where your photos, emails, and apps actually live. We call it the cloud, but it's really a massive physical warehouse full of computers, often sitting in a remote, empty field thousands of miles away from your home. Every time you tap your phone, your request has to travel all the way to that remote warehouse and back. That physical distance causes a slight delay. It also means a few large companies act as gatekeepers for almost all the information we create. But there is a different way to build this system. It involves blending physical neighborhood infrastructure with our digital tools. Instead of relying on faraway warehouses, the hardware and software work together right on your block. An Indian tech company called Pikk is actively working to shrink those massive server farms. They are taking the computers out of the remote fields and placing them directly onto local street corners. Bringing hardware back to the local level changes the math of the internet. It allows communities to reclaim both the speed of their connections and the ownership of their digital lives. To see how this works, picture a standard neighborhood street. Now, imagine replacing an empty patch of sidewalk with a small, modular booth. Pikk calls this structure a pikkstop kiosk. On the outside, it serves the immediate needs of the block. It has high-power cables to charge electric vehicles, and a modular storefront where local vendors can sell daily groceries. Tucked inside that same booth are compact, energy-efficient servers called data pods. These are essentially mini-computers built right into the structure of the kiosk. This diagram shows two different ways data can travel. On the left, a signal travels across the entire country to reach a central hub before returning. On the right, the signal loops quickly within a few city blocks. That short loop is called edge computing because the processing happens right on the edge of the network, close to the person actually using it. This approach turns underutilized urban real estate into high-speed tech hubs that serve the people standing right in front of them. Let's look at how you interact with that local kiosk using your phone. Pikk developed a dedicated camera application for this, called the pikkc app. Normally, when you take a photo with a standard app, the image is routed directly into a database owned by the company that made the software. They hold your memories on their machines. This flowchart shows exactly how the pikkc model works differently. Instead of passing through a corporate server in the middle, the software builds an encrypted bridge that connects your camera straight to your personal Google Drive. Because the app bypasses the company entirely, there are no tracking cookies profiling your behavior. The company holds zero storage of your media. It even includes simple physical features, like a shutter button you can drag anywhere on the screen so it's easier to reach with one hand. This is a decentralized solution. The software is designed so that it's physically impossible for the company to access your photos. But running advanced mathematics locally on small computers comes with steep technical hurdles. It takes immense processing power. Standard computers process information like a simple light switch. Everything is strictly either an on or an off. Advanced quantum computing, however, operates like a spinning coin. It can exist in many states at once, which allows it to solve incredibly complex equations. The problem is that building a true quantum computer usually requires a multi-million-dollar laboratory chilled to freezing temperatures. To get around this, Pikk developed an experimental method called the Q-spin framework. It's designed to simulate that spinning coin math using affordable everyday hardware. It starts with a special keyboard. A normal key is just a 0 or a 1, but these keys have sensors that measure the journey between up and down. As your finger moves, the sensor tracks the tiny wobbles, the speed, and the exact physical path of the press. The computer takes that messy human motion and turns it into a 3D map of the finger's movement. Because this map contains thousands of tiny, in-between data points, it can be used to simulate the complex, multi-layered states that quantum math requires. By using the natural imperfections of a human touch as a data source, the system can perform high-level simulations on a standard processor without needing expensive lab equipment. When you step back, you see a completely unified system. The math in the keyboard, the private app on the phone, and the local kiosk power source. Pikk built this entire network without relying on traditional venture capital. They fund their research by running an organic marketing agency, using their own service revenue to pay for the hardware. This model demonstrates that advanced technology doesn't have to be centralized in a few giant hubs. It shows an alternative path, where powerful tools are built sustainably and kept close to the people who use them. By bringing digital tools back to the physical world, the internet is moving out of the distant fortress and onto our street corners.